Yeah, welcome again. So this lecture is about NFTs. So I guess one type of native token that is worth talking about is these so-called non-fungible tokens. So yeah, maybe when people think about NFTs, they think about some fancy artwork or something, but in the end, all it means that that the NFT is basically a token that is non-fungible, meaning that there will be only one of them ever existing, which makes it somehow possible to link it to some real world item and kind of certify its uniqueness. So yeah, this is basically the definition, and now we want to think a bit about how we could implement this in terms of a minting policy. So here we list kind of three ways that one might come up with. Yeah, so when the transaction is minting some tokens, we have this this mint field. So maybe one kind of naive idea would be to simply check that this transaction only mints one token, for example. But of course, the reason this is naive is because we could just have other transactions that mint whatever else, right? So this doesn't work to ensure uniqueness. Then a second option here would be to use deadlines encoded in the minting policy. So basically to have the condition in the minting policy be that after a certain timestamp, no minting is allowed anymore. And this can work as a solution. So basically the creator of the NFT would mint the NFT before certain deadline, and then afterwards the policy is basically locked. So there can never be a second token from that policy ID. And the only disadvantage here is a bit that, of course, this requires the user, let's say, of the NFT to kind of verify themselves to if they really want to be sure that their NFT is unique, they would have to somehow go through all the minting events on that policy ID and check that before the deadline really nothing else has been done. Okay, so then maybe the last point, and this is maybe the best way here to do it, is that you construct the minting policy in such a way that it enforces a certain UTXO to be spent. So this UTXO will be a parameter of the minting policy. And this way it can ever really only, there can never be only one transaction that is valid under this minting policy, because afterwards the UTXO will be spent. So then nothing else can be minted. Okay, and this way, basically, by only looking at the minting policy validator, the users could already be sure that their NFT is really genuine. So yeah, of course, we are interested in how this can be implemented in OpShin. So let's maybe directly look at a smart contract here. So this is the validator, and we see, yeah, again, to remind ourselves that there's no datum in a minting validator, so only redeemer and script context. So that means the first two arguments here must be kind of the script parameters. So they will be, in the end, kind of baked into the policy ID. And the first one is this tx_outref. So this is just a reference to UTXO, to a transaction output. And the second one is the token name. Okay, so each policy ID in the end will be specific for one token name, namely the one of the NFT it corresponds to, and one tx_outref, which is the UTXO that kind of is uniquely consumed by this minting transaction. And then what do we do? Again, we check the minting purpose. So again, okay, this assertion fails if this is not a minting transaction. And then otherwise also we return this minting purpose because we will use it here to get the policy ID of the token that is being minted, which is also the policy ID. We use it here to get the policy ID of the token that is minted, which is also simultaneously the hash of this script itself. So then we use this function check mint exactly one with name. So I guess the name kind of says what it does. So it checks that this value we pass it contains exactly one token of this type and nothing else. And yeah, so the first assertion just checks that we do mint one amount of this token with policy ID and name accordingly. And then the second check, and I guess this is might be easily overlooked, but is of course super important because we need to ensure that really nothing else is being minted. So that really from this policy ID, we don't mint tokens with other names because if we don't check this, of course, then arbitrary other stuff could be minted and people might mistake it for the NFT. So after we have checked this, basically there's the other check here, which is this part where the unique UTXO thing comes in. So basically we check that that among the inputs of this, so we give it the script context, and then we look at the inputs of this script context, and we check that really the one that we're interested in here, this OREF parameter, is among those inputs. So it will be spent by the transaction. Okay, and this is basically the whole contract. So you can see that whenever this is spent once, so of course we need to somehow, when we compile the validator, we need to already know, we have basically ready the UTXO that we will want to spend. So we encode it as a parameter in the minting script. And then later we would do this one transaction where it's spent, and after that no transaction like this can ever go through. Okay, so in the next part of the lecture we actually want to deploy this minting policy and mint our first NFT. And so we will use again this kind of minting script we've been using before. So let's look at it again and see what happens in this specific NFT minting case. Okay, so the first part we've gone through now multiple times, so I will skip it. But then importantly here, if we're in this case of the NFT script, then basically we would prepare our UTXO reference. And for this, we simply take this UTXO that we want to spend anyways. So this will be our reference. And then, okay, now that we know this reference, we need to actually bake it into our minting policy. So we need to actually now recompile the minting policy with this parameter. And this is what we do here. So we pass the transaction output reference and also the token name, which we chose before. And we pass it to the build function, which recompiles the script with these parameters. And then this is the script that we will use later also to determine the script hash, which is the policy ID here. And yeah, the rest is more or less the same as before. So we sign the transaction and we submit it. And this is exactly what we want to do now. So I will just go back into our environment and again go to the week 5 and then let's run this and hopefully we get our first NFT mint And now the transaction has gone through, so let's have a put it in here, and we can see yeah, again it looks similar as before, now with our first OpShin NFT token name. And yeah, we have the mint here. Of course, if someone now actually wants to verify that this is really a proper NFT, I guess you would have to make the smart contract open source, and then they can compile it themselves and compare that this script that they see here is really matching the one that you give them, that they built, and you can verify the code. Okay, and this also concludes today's lecture. So we saw now again a similar minting process as in the previous lectures, this time with a slightly more complicated smart contract that really checks that the token minted is unique, which makes it an NFT. And yeah, I think we learned again a bit how to work with OpShin, and especially in the context of minting tokens. This also concludes the lectures from this week 5 on minting, and we will have one last lecture describing this week's homework assignment. So see you next time.